Hi girls, so tomorrow we're going to learn about sketching using the addition and subtraction of ordinates, which is just a fancy way of saying adding and subtracting y values from one another for two different curves. So what I've got here is I've got the two curves I'm going to draw. I've got y equals x and I've got y equals the square root of 4 minus x. So I start with my axes, and on those set of axes I draw the two curves that I'm adding together. So I draw y equals x, straight line, slope 1, blah blah blah. And then I will also draw the curve y equals 4 minus the square root of x, so it goes through 2, minus 2, and 2 on the y-axis. And the fact that that has a restricted domain tells me that the whole thing has that exact same restricted domain between 2 and minus 2. So all that we have to worry about in this topic is saying fix a particular value of x, and from that point add the two y values together that are there and get the new y value for the final curve, right? And this works whenever I've got the addition of two curves that I know how to sketch individually. So I know how to sketch x, I know how to sketch the square root of 4 minus x and things like that. So I take those two things together, sketch them, and then add them. So if I take any example I like, so if I take, I don't know, x equals, let's say that's 1, right? Let's say that's 1. So I take the y value of the yellow curve here, which would be 1. I take the y value of the green curve here, which would be root 3. It doesn't really matter. We're not too concerned about precision for this topic. But the point is that I take these two numbers, which are both positive, and I add them together, which gives me a bigger positive number than both of them. So the curve would pass through that point there. Right, I could do exactly the same thing here. I can say, what's the y value here? What's the y value here? Add them together. Now let's, for argument's sake, say that that is a bigger y value than that. They look pretty close, but let's say it's bigger. So that would mean that the curve would pass through about there, somewhere above the x-axis. Right, so that's what we're going to do. So I'll get rid of those points and then I'll do it in full. So first thing I prefer to do is to look at the kind of what you call the critical values, I guess. So they're points like where it goes through 0, because when one of the two curves goes through 0, it means the y value has to be exactly on the other curve. So when x equals 0, the yellow curve is 0, so my new curve, which I'll just draw in blue, will pass through the green curve. Same thing here when x equals 2. The green curve is 0, so it will meet the yellow curve exactly, like so. And same thing here at minus 2. Right? I will meet the yellow curve exactly because the green curve is 0. Next, I often like to, if I've got a positive and a negative curve, it's always a good idea to look for where they're both roughly equal. So I'd say that's about here. Right? So I could do it algebraically, it's not too hard, but I don't need to for this topic, generally speaking. But I mean, I would normally do it. I'd set them equal to each other and I'd solve for x using a quadratic, get whatever that is. But the point is that here, at this point here, the green curve is the same amount above the y-axis, the x-axis, as the yellow curve is below the x-axis. So I pass through the x-axis on my new addition curve. And then often I like to think about what happens here when the two curves are equal. Well, when the two curves are equal, I double the x's, double the y values to get the new y value, and I get something like that. Now, if you think about it in terms of like geometry, what I'm doing is I'm adding a line to a circle, and it turns out that my answer looks something like a tilted semicircle. Right? You can see it's a little bit flatter and things, and I'm not sure, but I don't think it is actually a tilted semicircle. I think it's more of an ellipse or an oblong or an oval, depending on which word you like to use. But it should make a little bit of sense at this stage. So if you think about what's happening about here, right? I'm thinking about adding the circle, which is the more complicated thing, to the line, which is quite simple. And over here, the circle gets much smaller quite quickly. So the blue curve should get close to the yellow line because I'm adding much smaller positive values to whatever the yellow line happens to be. I don't care what those values are. All that I know is that I'm adding something to it, so it should be above it. And I should get very close to it because this circle gets close to 0. Exactly the same analysis at this end. I'm adding the circle to the line. The circle is getting smaller, but it's positive. So the blue curve should be above the line, but getting very close to it. Okay, and they're the kinds of analytical tools that we need to be able to use for this topic. It's worthwhile now having a go at a different one, if you have the time, on this quite nice last day of the holidays. So y equals x squared plus root x, for example. I'd encourage you to try sketching that using exactly the same technique, having a green curve for that one, having a yellow curve for that one, and drawing them together and seeing what you get. And then when you're finished, I'd chuck it in Desmos and see how your curve compares. Whenever you're doing this kind of stuff in Desmos, it's always worthwhile plotting 3 curves, not just the final one that you want to draw. I'd always suggest you plot this part, and it does different colors for you, and then plot the whole thing and see it building on itself. Alright, I'll see you bright and early tomorrow morning.